Okay, here we are, a new chapter in math. We are on chapter 7. We're going to be looking at decimals. So let's look on page 153 in your book where it says chapter 7 decimals. All right, so in this section, this lesson is a little bit longer. It really shouldn't be anything new to you, but make sure you pay close attention because this is actually a life chapter, I guess we could call it. All right, so throughout the course, we've been using the decimal system, our base 10 place value system, to represent whole numbers. It's time now to look at extending this system to also represent partial quantities. Now, the word decimal, I'm reading right there on the middle, right underneath 7.1, and this is in parentheses. The word decimal actually comes from the Latin root decimus, which means tenth. So most of us were exposed to representing partial amounts in the decimal system since we were little, mainly because we use them to write parts of a dollar. But let's take a closer look at this notation and at how to use it as an effective tool in our mathematical toolbox. Okay, so look at the decimals. It says extending the notation. To better understand how to use our decimal system to describe partial quantities, picture a grocery store without decimals. How would you describe the price of items less than $1? Well, you could use fractions. So there you have a donut, 4/10 of a dollar. Then you have a, whatever that is, for 2/5 of a dollar, a sandwich, I guess. And then a croissant for half a dollar. Okay, so most likely you would want to write all the fractions with the same denominator to make them easier to compare. So basically you would take, so the denominators are 10, 5, and 2, so you would just want to write them like they did on the bottom, give them common denominators. It makes it easier to read. And they used 100 because there's 100 cents in a dollar. So it makes sense to use 100 as the denominator. So if you change 4/10 to, let me show you this. If you change 4/10 and you want it to be an equivalent fraction with 100 on the bottom, you say, okay, 10 times 10 equals 100, so 4 times 10 would be 40. And that's how they get that. Okay, and that's what they did with the 2/5, and that's what they did with the 1/2. Okay, I need to change my pen too because I need it to be a little bigger. There we go. Okay, so let's turn the page. Now, it's easier to compare the cost of each item. We could further simplify expressing these costs by writing these costs in our base 10 decimal system, letting the place or the location of the number show its denominator. So you see that donut went from 40 over 1, actually it went from 4/10 of a dollar. An equivalent fraction with 100 on the bottom based off of a dollar would be 40/100ths. Okay, then they wrote it like with decimals. And you say that 40 cents. And then the sandwich 40 cents. And then 50 cents. Let's take a look at what we just did. We basically added what we call a decimal point to the right of the ones digit, an extended place value to represent partial quantities. Now, each place to the left in our decimal system is worth 10 times the previous place, and each place to the right of the decimal place is worth 1/10 of the previous place. The decimal point separates the whole numbers from the partial ones. So look there at your right in the middle of page 154. This is a very good, you might even want to write this down on a note card or a piece of paper or something. Kind of shows you the place value in our base 10 system to the left and to the right. Now, of course, to the left, it's, everything you've learned since, kindergarten. All right, now, let's look at the gray box where it has the arrow. We're going to begin now using a dot rather than the X for the time sign to represent multiplication. Since an X has a different meaning in algebra, it's important to become familiar with other ways to show multiplication. So just remember, with 4 and then the time sign using an X, 4 times 2, well, we're going to use 4.2 because the dot also means multiplication. Or you could do it 4 with the other number in parentheses right beside it. All those mean the same thing. Okay, but now we're not going to use the X anymore, so keep that in mind. Whether representing a partial quantity or a whole one in the decimal system, the place or the location of each digit determines its value. Notice how the place of the digit 6 gives it radically different meaning. So let's look at the top of 155. Okay, now if you have 0.006, now that 6, if you'll look back over on 154 at that place value, okay, line those up in your mind. Now you see the decimal. Okay, the 0 to the left would be 0 ones. Okay, now the first 0 to the right would be 0 tenths. And the next 0 would be 0 hundredths. Now the 6 comes in the thousandths place. So you would say 6 thousandths, like it's written, or as a fraction, 6 1,000ths. Okay, and then here we go with the one underneath it, 0.06. That 6 is in the hundredths place, so you would say that's 6 hundredths or 6 hundredths written as fraction. Okay, now there's 0.6. That's the same as 6 tenths because it's in the tenths place, or 6 over 10, same thing. Okay, and then just the whole number 6 is 6 ones, or just 6. Okay, and then 6 and a 0 is 6 tens or 60, and then 600 is 6 hundreds or 600. Okay, now that takes that 6 on all the different place values using the decimal system in our base 10 system. So from now on, we'll refer to partial quantities written in the decimal system as decimals. All right, so now we're going to switch between fractions and decimals. Okay, now the example here on page 155 is express 0.6 as a fraction. All right, so what fraction does 0.6 represent? Well, the 6 is in the tenths place. So the amount of that would be 1/10. So you're going to express the 6 as 6 tenths. Okay, now let's express 61 hundredths as a fraction. So again, the 6 is in the tenths place, so you have 6 tenths. However, we also have a 1 in the hundredths place, giving us 1 100ths. So we have 6 tenths plus 1 100ths. Now, rewriting with the same denominator and adding it gives us 61 hundredths, because you would have to change that tenths to a hundredths by by multiplying 10, doing the same to the top. So you'd come up with 61 hundredths being equivalent to 6 tenths. Because remember, you can't add fractions until they have the common denominators. So then you'd add those and you'd have 61 hundredths. And then to write that as a fraction, a decimal would be 0.61. As a fraction would be 61 hundredths. Okay, all you really need to do is remove the decimal point and add the denominator from the rightmost place value that's represented. Now I'm on the gray box at the bottom of 155. You can always look at the entire decimal part of a number as a fraction of the rightmost decimal place represented. So look at the last example on 155. You have 612 thousandths. That's how you would say that decimal. 612 thousandths. Look at this board. I'm going to write it up here. I just want to make sure you understand. Okay, 612. Now, there's nothing in your whole numbers, okay, but you have to have that to show, because if you didn't, this would just be 612. So to have this decimal right here, you say this number just like it is, 612, but then you have to remember the place value. This is the tenths. This is the hundredths. And this is the thousandths. Now this is the far right. This is as far right as it goes. This is what it means when it says the rightmost decimal place. Okay. So now you say this place value. So 612 thousandths. That's where that comes from. Now you can also do this as a fraction, 612 thousandths. Now, if you have 4 digits, you always want to put your comma. Okay, these are the same. They're the same thing. All right, let's look on page 156. Now, we could then simplify this fraction if we needed a simple answer. Okay, so this fraction can be simplified. Okay, at the very top there on page 156, it shows to divide both of those by 4. So if you divide this by 4, you get 153. And then if you divide 1,000 by 4, you get 250. Whoops, I forgot my 3. Well, this is crazy. Okay, so now it gives us a new one to do. Let's cut this out. Well, am I ever going to get it all? There we go. All right, now, so express 4/5 as a decimal. Okay, let's read what it says. Remember, our decimal place value system expresses partial quantities in terms of tenths or multiples of tenths. So to write this quantity as a decimal, you have to make this into a denominator of 10 or a multiple of 10. Okay, so what do we have to multiply these by to make 10 on the bottom? Because you can't write a decimal, because remember decimal comes from decimus, which means tenth. So anytime you need to put something in a decimal form, you have to multiply it. If it's a fraction, you got to multiply the denominator by 10 or something, a multiple of 10. So this would be times 2, so this would be times 2. So our equivalent fraction would be then 8/10. Okay, so then you could write 8/10 as a decimal, because this is your tenths place, right? All right, so look where it says applying it, writing checks, in that gray box on page 156. When writing a check, we write the amount using our decimal system and then rewrite it in words. Instead of using words, though, the cents are typically written as a fraction. Notice that the fraction takes up less space than the words 27/100ths would. So if you're writing a check for $23.27, you would write the numbers there where it says dollars, 23.27. But then underneath pay to the order of, you would have to write it out. 23 but the cents we always write as a fraction. Now, this is just FYI. If you're writing a check for, say, $25 and there's no cents, okay, you would write the words 25 and no 100. That means no change. Okay, that's just FYI. All right, let's look at this next little section here where it says adding zeros. Okay, it says you can always add zeros to the right of a decimal point. Okay, here you have 0.6. It's the same as each one of those, no matter how many you add, it's the same number. It does not matter. Adding or removing a 0 to the right of the last number of a decimal does not change its value. Adding or removing a 0 actually multiplies or divides the fraction by 10/10, which is worth 1. So if you have, now let's look at the top of page 157. If you have 0.6, that's the same as 6/10, correct? Okay. Now if you multiply 6/10 by 10/10, you get 60/100ths, which, look at that written as a decimal, 0.60. Okay. For example, when working with money in America, we represent amounts in terms of dollars and cents. Since there are 100 cents in a dollar, we always represent the partial amount of a dollar in terms of hundredths. For example, rather than writing 0.1, we would add a 0, making this 10 cents, which is essentially just 1/10. Okay, now it's easy to see that it represents 10 cents. Okay, so that's just the way we write it. Okay. Reading partial quantities in the decimal system. 0.1 could be read 1/10, just as you would read 1/10 as a fraction. 3.24 could be read 3/2400ths. Notice the "and" used to break up the whole and partial portion of the number. Now let's stop right there just for a second. When you were younger or older, and let's just say you had this number, I'm just making up some number, okay, 32,614. Now, A lot of kids want to say, or a lot of people want to say 32,614. I don't know why, but they always want to say that. No matter what the number, they always want to add "and" in there. Never add "and" unless it's at a decimal point. Your decimal point equals the word "and." If you say 32,614, that gives the impression that there's a decimal there. That would not be correct. Okay, so only use "and" when there's a decimal. Sometimes we say point, so sometimes you'll hear 0.1 read as 0.1 and 3.24 read as 3.24 or 3.24 instead. Now it's not wrong, it's just not real correct, I guess you could say. Or if you were dealing with money, we'd read 0.1 as 10 cents and 3.24, $3.24. So those would be correct if you're thinking of money. All right, so I don't think the look at history, I read over that gray box at the bottom of 157. I don't think that's important to what you're doing. It just kind of talks about what they did in history when it came to decimals. So if you want to read over that just to kind of get some information, you can. And then there's the keeping perspective on the back on page 158. I do want you to look at the second paragraph on keeping perspective. The account of King Nebuchadnezzar from Daniel 4 really brings this point home. King Nebuchadnezzar boasted to himself about Babylon, taking credit for building such a great empire. God humbled him and made him like the beasts of the earth. God was showing him he could not even think or function apart from God's enabling. We are utterly and completely dependent on God for everything, including the ability to think and name quantities. All right, so your assignment is going to be to do worksheet page 7 or worksheet 7.1 front and back. I'm not going to help you with it. It's pretty simple. It goes over everything we did. Now it does, I think on number 2, you can use your calculator, so you can have it available for that. So anyway, go ahead and read the top part, read the whole thing. There's a little section at the top you'll want to read. And I do think I'm going to take a grade on this. This should be very simple. Again, it should not be anything new to you. If you do need help, though, let me know. That's all for today.